Hey guys, Kate, so we're going to go over the next lesson. Last two lessons have been mean, so finding the average of a set of data. The next lesson that you should have gone over yesterday was going over median and mode. So we're building off of that now, and we're going to be talking about measures of variation. So our I can statement for today is I can find measures of variation. Now we're actually going to split this lesson into part 1 and part 2. The reason why is because there's a lot of stuff that's going on in this lesson, and I really want to make sure that you're understanding it. So today we're going to focus more on finding measures of variation, and tomorrow we're going to focus more on identifying outliers. You'll understand what that means as we learn about it. But before we move forward, I kind of want to go over vocabulary because that's going to help you a lot with this lesson and the next couple of lessons that we're going over. So starting with vocabulary, measures of variation. Now, this whole chapter talks about different ways to analyze data. We've talked about finding the average, the mean. We've talked about median. We've talked about mode. Now, measures of variation shows us how a spread of data looks. And what I mean by a spread of data is how kind of the range of it and how far away all the different data sets are. I'll use this as an example. So let's say that we take 2 tests in our class, okay? I'm going to say that these are scores of 7 students, okay, just as an example. If we look at set 1 of the data, it says that our scores were 72, 69, 80, 77, 83, 90, and 87. Okay, if we were to look at that set of data, sure, there are some numbers that are significantly higher or significantly lower, but really they are kind of close-ish together. 69 is the lowest that we get, 90 is the highest that we get, so there is a spread of data there between that range of 69 and 90 and everything in the middle. There's this spread going on. Now, if we were to look at set 2, we've got 92, 83, 76, 77, 69, 70, and 26% on a test. Now, I want you to think really quickly. I'll explain, but first I want you to think to yourself, when you look at set 1 and set 2 of the data, which do you think has a wider spread? Okay, if you're thinking that set 2 has a wider spread of data, that's true because this 26 is there. Okay, we have this wide range, and then we've got all these different numbers kind of in between 92 and 26. Okay, there's more of a spread going on. Okay, we're looking at measures of variation. How much does the average or the mean, well, that's the same thing, the average or the median or the mode, where do they kind of fall in that spread of data? Okay, so we're going to talk about that a little bit more, but that's what measures of variation is, okay? Now, we're going to move further down. I am actually going to jump down to range first. So I'll just put a star next to the ones that we've talked about. Range right here. When we're talking about range, we are taking the highest number in a set of data. So in this case, for set 1, the highest number in the set of data would be 90. And then we are taking the lowest number in the set of data. In this case, it would be 69. And we are finding the difference between those two numbers. So we're finding the difference, which means we're going to use subtraction. So you would do 90 subtract 69. Okay, we're going to do that really quickly. And we get 21. So our range in that situation would be 21. Okay, if we were to do the same thing, I'm actually going to use a different color so that it doesn't blend in with the vocabulary. So the range for that one was 21. And then if we look down here on set 2, the largest number that we have is 92, and the lowest number is 26. So again, we are going to look for the difference between those two numbers to see what the range of our data is. So it would be 92 minus 26. Okay, so I'm going to do that real quick. And we get 66 would be our range. So when we're looking at that range, that kind of tells us how far is all this data spread out. Okay, so I want you to know what range is because we're going to get a little bit more into it as we look at quartiles and the interquartile range, which is a huge part of what we're covering today. Outliers here, we'll cover a little bit more tomorrow, but what an outlier is numbers that are so far away from the rest of the data. For example, if you were to look 26, it is far enough away from all those other numbers that it could potentially be an outlier. And there's an algorithm, formula that will help you determine whether or not that is an outlier. And we're going to go over that tomorrow. So just keep in mind what an outlier is from what we've talked about, and then we're going to talk about it a little bit more. Today, we're going to talk a little bit more about those 4 different terminologies and what they mean. So I'm actually going to, let's start by just saying quartiles, and I'll show you what that is. Quartiles. Does it have a root in it that sounds similar to one of the roots that we've gone over this year? Just think about it. Okay. Quartile. It's not quad, right? But it has a similar meaning. Quartiles, quarter, okay? We're taking this data and we're separating it into quarters. We're putting it into fourths, okay? So before I move forward, I'm actually going to erase this and keep this data set here. Whoops, let's not have this whiteboard fall over. Okay, so the terms that we're going over, we've got quartiles. There's the first quartile. There's the third quartile. And one of the most important ones to know, because you're going to need this for when you're trying to find outliers, is the interquartile range. Okay, so, I don't want that to fall. Okay, so I'm actually going to start by telling you what you're going to do. Before you're able to figure out what the quartiles are, you are going to need to order your data from least to greatest. Okay, so very much like what you would do if you were trying to find the median, that's what you're going to be doing. Okay, so first, order data from least to greatest. Okay, so we're going to try doing that really quickly with this first set of data. So we see here that the smallest number we've already identified is 69. So we know that 69 is our smallest number in our set of data. And then the next one would be 72. After 72, we've got 77. Then we've got 80. 83, and 87. Okay, so we've gone through all of our data. It's in order. And I want you guys to think about median. When we're finding the median of a number, we're going to do the exact same thing here. Okay, we've got 1, 2, 3. Oh, I'm missing a number. What number am I missing? 2, 3, 80, 87. Oh, I'm missing 90. 90 is the highest one. Okay, so in our set of data here, we've got these 7 numbers. We want to find which one's in the middle. We want to find the median, okay, what we went over last lesson. So we're going to do that. We've ordered them from least to greatest, and we are going to find them. I'm not going to cross them out because we're going to use it a little bit more. And we know that 80 would be our median, okay? Basically, what we did with the median is we just cut this set of data in half. We've got this 50%, that's below 80, and we've got this 50% that's above 80%. We've cut it in half, but now we need to get it into quarters, okay? What do you do to get a half into a quarter? Think of fractions. You're gonna divide it in half again. So right here, you're gonna see what is in the middle here, okay? Between the smallest number in the set of data and the median, okay? I want you to think of what you think it might be. Okay, and I'm gonna just show you right here. That is what the first quartile is. Okay? Because it is in between the lowest number and the median. Okay, we are cutting it into fourths. So with that in mind, I want you to think about what the third quartile probably is. Okay? I need to just hang this on my wall so it's not wobbling. So that would be our third quartile. We have now divided our data. Lost the lid. We have divided our data into 4 separate pieces. We have put it into quarters, quartiles, okay? So now that we've done that, let's check this out. We've got the smallest number, quartile. First quartile, second quartile, third quartile. Well, that's not what they're called, but first quarter, second, third, fourth, okay? Here's the first quartile, there's the third quartile. It's right in the middle of the smallest number in the median and the greatest number in the median. Okay, I only have a couple more minutes because YouTube will only allow me to do 15-minute videos, but we're going to talk about the interquartile range really quickly, okay? So the interquartile range, I want you to think about, again, roots, interquartile. Inter is like inside or between, among people, right? So inter is going to be in between quartiles, okay? Interquartile range. So we're actually going to just be looking at the range between the third quartile and the first quartile. So with the normal range, what we were talking about before, where we took this first number, the greatest number and the smallest number to find the range of data, see the difference. We're doing the same thing, but now we're doing it with the interquartile range. We're doing the difference between the third quartile and the first quartile. So we're going to do that. We've got 87 as the third quartile, and we're going to subtract 72 because that is the first quartile, okay? I'm just going to do Q3 and Q1, okay? Because that one's the third, that one's the first. Now we're going to find the interquartile range. We're going to subtract. So 7 minus 2 is 5, 8 minus 1 is 7, 8 minus 7 is 1, and we've got 15 as the interquartile range, okay? You need to be able to do this. Tomorrow when we are looking for outliers, you cannot find and identify whether or not a number is an outlier without knowing the interquartile range. So you have to know this, okay? If you need to rewatch this video over and over again, go for it. I do have like 1 more minute left, so I'm going to see really quickly if we can hurry up and find the interquartile range for the second set of data, okay? We've got 1 minute. So the smallest one, because we're ordering data from least to greatest, the smallest set of data here is 69. No, actually it's 26, sorry. And then we've got 69, and then we've got 70, then 76, 77, 83, and 92. Okay, so now that we have that, we need to be able to find the median. So we're going to find the median. The middle number is 76, would be median. And now we need to find what's in between smallest and median. It's going to be 69, would be first quartile. And then we would find the third quartile. And then now that we know what the first and third quartile is, we would subtract them. Okay, I have to end this now or else it won't upload.